In this video, I'm going to go through a demonstration of the distortion versus frequency test. And this is another one of these bread and butter tests that everybody has and expects. So let's walk through this. To begin with, it does very much what you would expect. When I click Start, it's going to sweep at the frequencies between 20 and 20 kilohertz, 1 step per octave. And at each step, it's going to calculate the distortion. Now, because this is going step by step by step, these mini plots here show each single step. So if there's something going wrong, you'll see it right away. And when it finishes, we get a graph of frequency at the bottom, amplitude on the left. So as we can see with the device under test here, which is an old preamplifier, the distortion for some reason goes way up at a kilohertz and then goes back down at high frequencies and low frequencies. Before I do anything else, let's bump this to 192K so that we can get good distortion figures at 20 kilohertz by extending our frequency range. All right. Now, in addition to total harmonic distortion, we can show THD plus noise, and we can show all sorts of other stuff. Let me hit this and they'll all come on, and we can see that we've got the magnitude, THD, THD plus noise, the noise floor, as well as the noise density, and then the first few distortion components. Or I could turn them all off and we can just look at, for example, THD plus noise. And as I move the mouse, you'll notice on the right, the cursor updates. And let's go back to here for a second. It'll show you every single thing for each frequency numerically. Go back to here, let's look at that. Okay, so our THD plus noise at a kilohertz here is like, minus 75 dBV or 55 dB down at a tenth of a volt. Just to check, let's go back to spectrum and we'll run a 1/10 of a volt sine wave and take a look at it. Let's bring up our summary data here. And we see that the THD is indeed negative 55 dB or almost 1.5 or 2%. And yes, that matches up exactly with what we're looking at here. So, okay. So these are the sort of standard things you're going to want to see. If I increase the number of steps per octave, we will get more data points. I can't decrease it below 1, but I can certainly change the frequency range. In addition, there are a number of things we can do here. One, you can turn off those mini plots if you never want to see them. I kind of like seeing them to make sure that the testing is all working. But more importantly, you can actually do a pretty cool test. This is a new control, this pop-down arrow. What that means is we can have more than one voltage here. So let me add another one. In addition to a tenth, let's do a half a volt, and let's do 2 volts. And that'll show up with little semicolons between them. So you could actually type this out, or you can just go here and do it in a convenient user interface. And let's get this back down to 1 so it goes quickly. Now let me run this again and let's look at THD plus noise. Okay, and I'll click Start. It'll erase the old chart and start doing the new one. And now what is going to happen is that it will run this sweep at a tenth of a volt. And then it's going to run this sweep again at a half of a volt. And then it's going to run the sweep again at a volt. And what you'll notice is when it got to a volt, it raised the attenuation because I'm auto ranging. So doing auto ranging is a really good idea if you're going to test at more than 1 voltage here. And here we have our chart. These are the THCs, and you'll notice that the legend shows the voltage. So if you want to see which one is the 2-volt one, you can turn it on and off here. And if we turn this on for all of them, it's going to be a mess. All right. So now we have all of these statistics at all 3 of the test voltages. And if you want to turn off only one of them, like 100 millivolts, if I hold down the Shift key, when I click this, the whole range will go away. So that's just holding down the Shift key, and now we're back to 2 volts, or 2 volts and half a volt, or all three of them. And similarly here, let's turn them all off and just look at THD or THD plus noise or the noise floor. Now note some of these are missing. Let's go ahead and fit to data. And there we go. Let's get rid of the THD, and you see something interesting is that at the lowest frequency and highest frequency, the noise floor is kind of setting THD plus noise. And if we look at THD, I'll bet we see that. Sure enough, we can see the THD's dropped off, but the noise is keeping the THD plus noise up. So these are all interesting statistics, and this is in dBV. So not surprisingly, at 2 volts, let's change this color for a sec. This is palette index 19. Let's make it a green so it's distinguishable here. There we go. All right. So not surprisingly, at 2 volts, we have more absolute distortion than at 100 millivolts. But what about as a percent? Just simply go up here and switch it to percent. And we now see that same chart at a percent, although interestingly, these are flipped. Now the 2 volt is the lowest and the red is the highest. So the absolute went up, but it didn't go up as much as the fundamental did. And that is a pretty good summary of distortion versus frequency.